Welcome to the mole and stoichiometry tutorial number 2. For this tutorial, you will need your periodic table and solubility chart, a calculator, a map of mole lands, and the worksheet that accompanies this tutorial. This tutorial is an extension of tutorial number 1, and so we'll be practicing the same thing that we did in tutorial number 1 here in tutorial number 2. So for our first bit of practice, remember we must always start by correctly writing the chemical equation and balancing it. So we have here that solid aluminum reacts with chlorine gas. So you have solid aluminum, there it is, and it is reacting with chlorine gas. Now remember, chlorine is diatomic, so we have that right there, and it's a gas. Now we must evaluate what type of chemical reaction this could possibly be. You have aluminum and chlorine. They can't swap places, so it's not single replacement and double replacement. It's not combustion because we don't have CHO, and then it's not decomposition because we don't have one reactant breaking down into two. So that only leaves one option. This must be a synthesis reaction. And so aluminum and chlorine are going to combine into one product, which we must use their oxidation numbers to arrive at the correct formula. So we have AlCl3. So there's our correct chemical formula. Now we must balance. So let's take a quick look at this. We have 2 and 3. So I'm going to place a 2 here, 3, and a 2. And remember from the last tutorial that these coefficients represent the number of moles. So we have 2 moles of aluminum reacting with 3 moles of chlorine to produce 2 moles of aluminum chloride. And if you check solubility, this is aqueous. So now that we have our chemical equation written correctly and balanced, we can take a look at our first problem. So this one asks us what mass of chlorine gas is required to react with 10 grams of aluminum metal. So we're wondering what mass of chlorine gas is required to react with 10 grams of aluminum metal. So if you look back at your map of mole land, you'll see that you're going from the mass of one element here to the mass of another. So we must first use molar mass, then our mole ratio, and then molar mass for chlorine to find the mass of chlorine gas that's required. So let's start with our 10 grams of aluminum. So we must first use our molar mass to get to moles of aluminum. So there are 26.98 grams of aluminum per mole of aluminum. Now we can use our mole ratio. So drop down your aluminum here. You have 2 moles of aluminum, and we have 3 moles of chlorine. Now that we are in moles of chlorine, there's just one step left. We must find the number of grams of chlorine. So our molar mass of chlorine, we have 35.453 times 2, so that is 70.906. So you should be able to calculate this answer now. 10 divided by 26.98 multiplied by 3 divided by 2 multiplied by 70.906. And you should arrive at your answer of 39.4 grams of chlorine gas. Now, in looking at the next problem, it asks what mass of aluminum chloride could be formed from 0.100 moles of aluminum metal. So we want to know what mass of aluminum chloride would be formed from 0.100 moles of the aluminum metal. Let's take a real quick look at the map of mole land. We see here that we're starting with moles of aluminum metal, and we want to find mass of a different compound. So we're going to start with moles, use the mole ratio bridge, and then use molar mass to find the number of grams of aluminum chloride. So looking back right here, we're going to start with what we're given, 0.100 moles of aluminum. So since we're already in moles, we are going to begin with our mole ratio. 2 moles of aluminum with 2 moles of aluminum chloride. And then lastly, we are in moles of aluminum chloride here, so we are going to use molar mass. 1 mole of aluminum chloride has a molar mass of 133.339 grams. So then you can calculate, and you should arrive at your answer of 13.4 grams of aluminum chloride will be produced. So that is the end of the second tutorial. The next tutorial we will be looking at how to use or how to calculate molarity of a compound. So thank you for tuning in.